So this first one, if I'm looking to find the domain, I need to first look at what kind of root this is. Well, it's a square root, which means that it's an even root. If it's an even root, I'm worried because then I have to make sure that the inside of the root needs to not be negative. It needs to be greater than or equal to 0. Well, what's inside of my root? Well, in this one, it's an 9x plus 18. So that entire inside part, the 9x plus 18, needs to be greater than or equal to 0 to avoid negatives. Well, luckily we can solve this like an ordinary inequality by starting by subtracting 18 from both sides of the inequality, which gives me a 9x is greater than or equal to negative 18. Then dividing both sides by 9 on the inequality gives me that x needs to be greater than or equal to negative 2. Remember, though, we can't leave our domains looking like this. We need to write them in interval notation, meaning they should have infinities and parentheses and brackets, that sort of thing. So I need to turn this answer into a graph to figure out what its domain will look like in interval notation. Well, greater than or equal to 2 means that the graph will point to the right. The equal to means it will have a bracket at negative 2. So to convert this into interval notation, reading this from left to right, we'll start at the negative 2, which has a bracket, and it goes off forever towards infinity. So we'll say comma infinity, which always will have a parenthesis, so we'll stop with a parenthesis. So that's our official domain. Bracket at negative 2, comma infinity, which has a parenthesis. Let's look at another one. Let's look at B. Again, we run into the same kind of issue. What type of root are we looking at? Well, it's a square root, meaning it's an even root. With an even root, we are worried that the inside, whatever it may be, needs to not be negative, meaning it needs to be greater than or equal to 0. Well, in this particular one, what's inside of the root is just it's a 2 minus 0.5x. So we want that 2 minus 0.5x to be greater than or equal to 0. So again, we'll solve this like we would a regular equation by subtracting both sides by 2 to get the x by itself, which will leave us with negative 0.5x is greater than or equal to negative 2. Be careful here. We're going to divide both sides by a negative 0.5. What happens when you divide both sides of an inequality by a negative? It flips the direction of your inequality. So instead of a greater than or equal to, I'll now have a less than or equal to. So now I have x is less than or equal to. Well, a negative divided by a negative will now be a positive. Well, 2 divided by a half gives me actually 4. Just like the last one, though, I can't leave my domain like this. I need to write it in interval notation, so it might help me to go ahead and draw the graph. Notice this is a less than, so this time it's pointing to the left. It's still an equal to, so it's still actually going to have a bracket at the 4, though. So, but this time, reading it from left to right, it actually starts with the arrow, which means I'm starting at the negative infinity end and working my way up to 4 where I have my bracket. That's my answer for my domain. Here's another one, C. C is actually quite a bit different. And the only reason why it's different is because it's an odd root. It's a cube root. Don't care about what's underneath, just the fact that the type of root is an odd number. It's a 3. So remember, if it's an odd root, I don't actually need to worry at all. I can plug in positives, negatives, anything I want. So if I can plug in anything I want, my domain is actually quite simple. My domain here is going to be negative infinity to positive infinity. That's my final answer because we've got an odd root. Last one here. We're back to having a square root, so I do have an even root. So I am worried about this one. And whatever's inside needs to be greater than or equal to 0, meaning not negative again. Well, what's inside of this root is not that simple because it's actually got an x squared in it this time. So we've got an 81 minus x squared. That inside part needs to be greater than or equal to 0. Well, this is not just a straightforward inequality that we can solve. Although we have solved these in the past, we've solved them by graphing them, because if you have an x squared, you're looking at a parabola. Notice the x squared is negative, so it's actually a downward facing parabola. Question is, where does it cross the x-axis? Well, notice this actually can be solved. If you look at 81 minus x squared and look at when does it actually equal 0, well, if you add the x squared to both sides, that gives you a positive x squared. Well, this asks the question, what x value, when squared, gives you 81? Well, there's two of them. That happens when x equals 9 or x equals negative 9. So those are the two values where I'll cross the x-axis. So I'm looking at this parabola graph, and again, I'm worried about when is it greater than or equal to 0, meaning when is it above the x-axis? Well, that's just this little middle piece. Well, how do I write that out using interval notation? Well, this middle piece is greater than 0 or above the x-axis. If you read it from left to right, it starts at negative 9 and ends at positive 9. Now the question is, brackets or parentheses? Which one? Well, we have greater than or equal to, which means the equal to means we're going to be using brackets. So the domain of this function is negative 9 to positive 9 with brackets. That's our domain. Because the x squared tells me I have a parabola I have to graph.